So boys, this is a question about data. It's about a pendulum. We've taken 10 swings of pendulum of various lengths, and we want to calculate how the period relates to the length. What's further I have to do is calculate the average period for the length. So what I've done here is made a small error in my calculations, but we take the time for 10 trials for each of the 10 oscillations for each of the 3 trials, average that, get a time for 10 trials. We should in fact divide that number by 10 to get the average period. So it's 1.84 seconds. I'll make the same mistake in part 2. Right, we take the uncertainty, we take the longest measurement minus the shortest measurement, divide that by 2. Now uncertainty is 0.06 seconds for 10 swings, it should be 0.006 seconds for 1 swing. Right. The relationship, there's definitely a linear relationship there. So what we want to do is basically say that the graph is extremely linear, right? So this plot of L versus T squared indicates that L is proportional to T squared, or T squared is proportional to L, or T is proportional to the square root of L. That's the way you can put it. Right, there's a tiny y-intercept that is probably a systematic error. Right, it should be neglected. Right, we can then use the relationship we've got between length and period squared to predict the period of a pendulum. Right? So we start with that relationship from our graph. Now we want to use our line of best fit equation to do these calculations. Right? That's our best estimate of the relationship between L and T. So that equation is that L equals 0.2318 T squared. I can rearrange that to get T as a function of L. Right? And essentially we're extrapolating the line out to the length, a higher length, to get the time that matches that. We can get a period of 2.3 seconds.